Hi everyone, we're going to look at quadratic functions in table form. And we're going to use the table to figure out the vertex, the axis of symmetry, and the roots of the function. So what we have to do is think about what a quadratic looks like. A quadratic is always symmetric. It makes a U-shaped parabola going up, or it makes a U-shaped parabola going down. So we look for the vertex is where is the turning point? Where does it decrease and then start to increase? That's going to be the vertex. Or where does it increase and then turn around and then start to decrease? So this would be increasing, decreasing, decreasing, and increasing. So right here would be the vertex if it were upside down like that. So what we're looking for is when does it switch? So looking at your points here in the first table, we've got 5, 0, -3, -4, -3, 0. So you can see here we're decreasing down to -4. And then you start increasing up after -4. So at -4 is when it turns. So this point right here is going to be the vertex. And you can tell that that's right because on the other sides of it, they have the same y values. So on the left side of this, we've got -4 with -3. And then if you go two more out, we've got 0 on both sides. And then you can kind of figure out what would go next. It would be 5 over here with 0. So you can use that symmetry here to figure out where the vertex would be as the turning point. So the vertex coordinates are going to be at -3, -4. And if that's your vertex, the axis of symmetry goes right through that vertex. And it's always x equal to the x value of the vertex. So x equals -3 would be the axis of symmetry. Again, that's just the x value of the vertex. That's how you figure out the axis of symmetry. Now for the roots we look to see when are the y values equal to 0. Because those are also known as the x-intercepts, and that's when y equals 0. So we look for the x values that have a y value of 0. And those are our two red ones in the table. That happens when x equals -5 or x equals -1. So that's how we find the roots, given a table. For the next one here, we're going to do the same thing. We're going to look to see where is the turning point. So our numbers start low, and they start increasing up until 9, then they start decreasing after that. So that's going to be our turning point here right in the middle at 2, 9. That's going to be our vertex at 2, 9, which means that our axis of symmetry would be x equals the x value. So that's x equals 2. And then for our roots, we just look to see where are the y's equal to 0. So we look in our table for when the y's are equal to 0, and that happens here and here. So our roots would then be -1 and 5, the x values that produce a y of 0. One more example here, very similar. We just again look for the turning point. So the graph starts low, and then the table starts low, then it increases up past 0 to 1.25, and then it decreases after that. So this area right here would be the turning point, since we're increasing to there and we're decreasing afterwards. So that's going to be our vertex. So that's going to be at 1.5, 1.25, which means that the axis of symmetry is just x equals the x coordinate, 1.5. And then again, for our roots, we look to see where is y equal to 0, and that happens at 1 and 2. So our roots, or our x-intercepts, are at x of 1 and x of 2.